Have you ever looked up at the night sky, seen that faint, milky band of stars stretching from horizon to horizon, and felt a profound sense of both wonder and smallness? It's a feeling that connects us to every human who has ever lived and dreamed. But what if I told you that beautiful, sprawling home of ours is also a prison? A glorious, magnificent, inescapable prison from which humanity will almost certainly never escape. This isn't a story of failure, but a story of understanding our true place in the cosmos and finding an even deeper meaning right where we are. We begin with a number that is, for our minds, functionally infinite, 400 billion. That's the estimated number of stars in our home galaxy, the Milky Way. Our sun is just one of them, an average, unassuming star tucked away in a quiet spiral arm. For generations, science fiction and our own innate curiosity have painted a future where humanity sails between these stars and then, eventually, leaps across the void to other galaxies. We see galaxies like Andromeda in our telescopes, a beautiful spiral smudge in the constellation of the same name, and we imagine it as our next port of call. It looks so close, a cosmic neighbor we might one day visit. But this is where our human intuition, honed by millennia of navigating terrestrial distances, completely and utterly fails us. The universe has built walls around our galaxy, not of rock or force fields, but of something far more fundamental and unconquerable: distance itself. Andromeda isn't just far away. Imagine trying to send a message to a friend, but the message would only arrive after 100,000 generations of your family have lived and died. That's the scale we're talking about. And Andromeda is our closest major neighbor. The countless other galaxies we see with the Hubble and James Webb telescopes are hundreds of millions, even billions, of light years away. They are not destinations. They are ghosts. We are seeing them as they were when dinosaurs roamed the Earth, or even before the Earth itself had fully formed. This is the first and perhaps most humbling barrier. The universe is not an ocean we can cross. It is a collection of isolated islands, and the water between them is an abyss of space-time so vast that it renders all our concepts of travel meaningless. We are islanders, born on a beautiful, teeming island called the Milky Way, destined to only ever look out at the other islands as faint, untouchable lights in the sky. It's a staggering realization, but it's only the beginning of our cosmic confinement. The walls of our prison, we are about to discover, are actively moving away from us. So, the distances are immense. But what if we had infinite time? Could we, in some far-flung future, eventually cross that 2.5 million light-year chasm? Here, the universe introduces its second, and far stranger, insurmountable barrier. The universe isn't a static stage. It is a dynamic, expanding entity, and that expansion is accelerating. Thanks to the groundbreaking observations of astronomers like Edwin Hubble, we know that almost every galaxy is moving away from us. It is a common misconception to picture this as galaxies flying through space like shrapnel from a central explosion. The reality is far more bizarre. Space itself is expanding. It is the very fabric of the cosmos that is stretching, carrying the galaxies along with it. A helpful analogy is to imagine baking a loaf of raisin bread. As the dough rises, every raisin moves away from every other raisin. A raisin near the edge sees the raisins on the far side moving away much faster than the ones right next to it. We, in the Milky Way, are one of those raisins, and the farther we look the faster the other galactic raisins are receding from us. There's a strange and fascinating exception to this rule. Andromeda. Due to a quirk of local gravity, our two galaxies are actually on a collision course. In about 4.5 billion years, the Milky Way and Andromeda will merge in a spectacular, slow-motion dance of stars and gas to form a new, larger galaxy some have nicknamed Milkomeda. But this is a local, gravitational handshake in a universe that is, on the whole, flying apart. The truly mind-bending part is the acceleration of this expansion, a discovery that won the Nobel Prize in Physics in 2011. Driven by a mysterious force we've labeled dark energy, this expansion is getting faster and faster over time. This has a profound and permanent consequence. There is a point, a cosmic horizon, beyond which galaxies are receding from us faster than the speed of light. Now, you might think this violates Einstein's famous rule that nothing can travel faster than light. But those galaxies aren't traveling through space faster than light. The space between us and them is stretching so rapidly that it carries them away at superluminal speeds. It's like two people on an infinitely stretching rubber band. Neither is running, but the distance between them is increasing faster than they could ever run towards each other. The implication is terrifying and absolute. We can already see galaxies whose light is reaching us now, but which have already, in their own time, crossed this unbreachable cosmic event horizon. We are watching their past, but their present is forever beyond our reach. We can never go there. We can never send them a message. They are lost to us forever. Fast forward the cosmic clock. In about 100 billion years, this acceleration will have pushed every single galaxy outside of our local, gravitationally bound group beyond this horizon. The night sky for our distant descendants in the Milkomeda galaxy will be an almost empty, endless void. All the other islands in the cosmic archipelago will have vanished, their light stretched into oblivion, leaving our galactic home utterly and completely alone in the dark. The walls of our prison are not only unimaginably thick, they are expanding, ensuring no one ever gets out. Let's engage in a bit of fantasy. Let's say we could somehow survive for millions of years. And let's ignore the expanding universe for a moment. Could we simply build a fast enough ship? This is where we run headfirst into the warden of our cosmic prison, the unyielding laws of physics. The most famous of these is Albert Einstein's theory of special relativity. One of the theory is core tenets is the cosmic speed limit, the speed of light in a vacuum. A key consequence of this is the famous equation E mmc2. While most people know it means energy and mass are equivalent, its deeper implication for travel is staggering. As an object with mass accelerates closer and closer to the speed of light, its relativistic mass increases. To push it even faster requires more and more energy. To actually reach the speed of light would require an infinite amount of energy. It is a literal impossibility written into the source code of the universe. But what about getting close? Say, 99% of the speed of light. Even this modest goal presents an energy problem so colossal, it's difficult to describe. The energy required to accelerate a significant spacecraft, say, the size of a modern aircraft carrier, to 99%, the speed of light is greater than the total energy consumption of the entire human race for thousands of years. We would need to master matter-antimatter annihilation on a planetary scale, converting entire worlds into pure fuel just to get one ship up to speed. We are not talking about a technological challenge. We are talking about a challenge that defies the resource base of an entire solar system. This is the tyranny of physics. It doesn't just make intergalactic travel hard, it makes it fundamentally absurd from an energy perspective. But what about loopholes, you might ask? Science fiction is full of them. Warp drives, wormholes, hyperspace. The most scientifically plausible of these is the Alcubierre warp drive. The idea, proposed by physicist Miguel Alcubierre, is that you could theoretically warp spacetime itself, compressing space in front of a ship and expanding it behind. The ship wouldn't be moving through space, but would instead be riding a wave of space, allowing it to arrive at a destination faster than light would have without violating special relativity. It's a brilliant and elegant idea, but it comes with a catch so monumental, it might as well be a sign that says, "Do not enter." To create this space-time bubble, you would need something called exotic matter, matter with a negative energy density. We have never observed such a thing. While some quantum effects can create tiny, fleeting moments of negative energy in a lab, there is no known way to produce or contain it on the scale needed for a warp drive. We'd need a Jupiter-sized mass of this impossible material. It's like saying you can fly by grabbing a fistful of anti-gravity. It's a compelling concept that, as far as we know, has no basis in physical reality. The same goes for wormholes, theoretical tunnels through space-time. While they are valid solutions to the equations of general relativity, keeping one stable and open long enough for a ship to pass through would also require vast quantities of this same hypothetical negative energy matter. The laws of physics are not suggestions. They are the fundamental operating system of reality, and they have conspired through a combination of speed limits and impossible energy requirements to ensure that the gates of our galactic prison remain firmly and forever locked. Let's push our fantasy even further. Imagine that, by some miracle, we solve the energy crisis. We invent a propulsion system that defies known physics and can propel us towards Andromeda. We launch our ship. Now we face what might be the most insidious and complex barrier of all, the sheer biological and technological horror of a multi-million-year journey. We have a tiny bit of experience with long-duration spaceflight from the International Space Station, ISS. Astronauts on the ISS, orbiting for 6 months to a year, are in a relatively safe, heavily shielded environment within Earth's protective magnetic field. Even so, their bodies begin to break down. They experience significant bone density loss, muscle atrophy, a compromised immune system, and vision problems. Their DNA is constantly being damaged by the higher radiation levels. Now, scale that up from a 1-year trip in low Earth orbit to a 2.5 million year journey through the empty, hostile void between galaxies. The challenges leap from manageable problems to absolute impossibilities. The first killer is radiation. Intergalactic space is not empty. It is flooded with a constant, high-energy bath of galactic cosmic rays, GCRs. These are the nuclei of atoms, stripped of their electrons and accelerated to near the speed of light by supernovae and other violent cosmic events. They are incredibly penetrating. A few feet of aluminum, which is enough to shield from most solar radiation, would do virtually nothing against GCRs. Over a journey of millions of years, no conceivable amount of shielding could protect the crew. The ship's occupants would be subjected to a cumulative radiation dose that would shred their DNA, leading to catastrophic cancers, neurological damage, and certain death long before they reached their destination. But even if you could somehow solve the radiation problem, you face an even bigger one, the problem of a closed system. You would need to build a generation ship, a self-contained world capable of supporting a human population and its descendants for millions of years. This means a perfectly closed, 100% efficient, self-sustaining ecosystem. Every atom of water, every molecule of oxygen, every nutrient would have to be recycled with perfect fidelity, forever. This isn't a problem of engineering. It's a problem of thermodynamics. The second law of thermodynamics dictates that in any closed system, entropy or disorder always increases. Things break down, systems fail, contaminants build up, mutations occur. There is no such thing as a perpetual motion machine, and a perfect million-year ecosystem is a biological perpetual motion machine. We have already tried to create a much, much simpler version of this, and it was a spectacular failure. The Biosphere 2 experiment in the 1990s was an attempt to create a closed ecological system to house 8 people for just 2 years. Despite costing hundreds of millions of dollars and being planned by brilliant scientists, the project was plagued by disaster. Oxygen levels plummeted mysteriously, forcing them to pump it in from the outside. Most of the vertebrate species and all of the pollinating insects went extinct. The crew grew hungry and fractured into warring factions. The entire system spiraled towards collapse in less than 2 years. Now imagine trying to maintain such a system, not for 2 years, but for 2 million years. With no resupply missions, no outside help, every single mechanical failure, every crop blight, every mutated microbe would be a potential extinction-level event for the ship. The technological and biological complexity is so great that the probability of success over such a timescale rounds down to 0. The void between galaxies is not just empty, it is a biological and mechanical meat grinder. This brings us to the most profound and perhaps the most existentially terrifying reason for our confinement. Let's say we overcome it all. We break the laws of physics. We conquer biology. We cross the 2.5 million light-year gulf, and we arrive, finally, in the Andromeda Galaxy. What would we find? The sobering, statistically likely answer is nothing. Absolutely nothing. Our Milky Way galaxy contains up to 400 billion stars. We estimate there could be as many as 100 billion potentially habitable planets, worlds in the Goldilocks zone, where liquid water could exist. With numbers that large, the galaxy should be teeming with life, and at least some of it should have evolved intelligence and become technological, just like us. Over billions of years, a civilization could easily colonize the entire galaxy. So, as the physicist Enrico Fermi famously asked his colleagues over lunch one day, "Where is everybody?" This question is now known as the Fermi paradox. Despite the high probability of alien life, we have found 0 evidence of it. No signals, no probes, no megastructures. The cosmos is unnervingly silent. Decades of searching by programs like SETI, the search for extraterrestrial intelligence, have scanned the skies with powerful radio telescopes, listening for any whisper of technology. They have found only the quiet hiss of the cosmic background radiation, a deafening, galactic silence. This silence suggests the existence of something that scientists call the Great Filter. The Great Filter is a theoretical barrier or challenge that is so difficult to overcome that it prevents almost all life from ever becoming a galaxy-faring civilization. The terrifying question is not whether the filter exists, but where we are in relation to it. There are a few possibilities. One is that the filter is behind us. Perhaps the emergence of life itself is incredibly rare, or the jump from single-celled to complex multicellular life is a near impossibility. If so, we are one of the first, or perhaps the only, intelligent species in our galaxy. We are cosmically, profoundly alone. A far more chilling possibility is that the great filter is still ahead of us. Perhaps almost every advanced civilization eventually discovers a technology that inevitably leads to its own self-destruction, be it nuclear war, runaway climate change, an engineered plague, or an out-of-control artificial intelligence. In this scenario, the silence of the cosmos is a graveyard. The other civilizations existed, but they all failed to pass the filter that now lies in our own future. Whichever is true, the conclusion for intergalactic travel is the same. The immense, galaxy-spanning effort, the millions of years of travel, the sacrifice of countless generations, would all be for a journey to another empty home. We would arrive in Andromeda only to find another 400 billion stars with no one to talk to, just as empty as the one we left behind. We would have crossed the universe's greatest ocean, only to find a mirror image of our own cosmic loneliness waiting for us on the other side. The struggle would have been, in the most profound sense, utterly pointless. But let's explore one final, human consequence of this impossible journey. Let's imagine the ship makes it, and let's imagine they find a habitable world. What would become of humanity? An intergalactic journey doesn't just sever a connection with a home planet. It severs the very concept of a unified species. The first and most obvious fracture is communication. A simple hello sent from Earth to a colony in Andromeda would take 2.5 million years to arrive. A reply would take another 2.5 million years. A single round-trip conversation would take 5 million years. Humanity would be irrevocably split into causally disconnected pockets. There would be no shared culture, no trade, no exchange of information, no possibility of mutual aid. The Earth-bound branch of humanity and the Andromeda-bound branch would be, for all intents and purposes, complete aliens to one another from the moment the ship left. Over time, this separation would become biological. The colonists, isolated for millions of years, would be subject to the pressures of their new environment, adapting to a different gravity, a different atmospheric composition, a different spectrum of light from their new sun, and different levels of background radiation would drive their evolution in a new direction. This is a process we see on Earth all the time. A population of the birds isolated on an island chain will, over thousands of generations, diverge into multiple new species, each adapted to a specific niche. This is the story of Darwin's finches. Now, imagine that process on a planetary scale, over millions of years. The descendants of the human colonists would no longer be Homo sapiens. They would evolve into a new species, or perhaps multiple new species, perfectly suited to their new world. They might develop denser bones, different respiratory systems, or even new sensory organs. After a few million years, they would likely be no more capable of interbreeding with Earth humans than we are with chimpanzees today. They wouldn't just be culturally alien, they would be biologically alien. The grand unifying idea of humanity would be lost forever, fragmented into a diaspora of mutually incomprehensible, non-communicating, and biologically incompatible descendant species scattered across the void. The dream of spreading humanity to the stars would, paradoxically, result in the end of humanity as a single, coherent concept. The journey itself would destroy the very thing we sought to preserve. So, here we are, trapped. We are confined by unimaginable distances, pushed away by an accelerating universe, bound by the fundamental laws of physics, threatened by the hostile void of space, likely alone in a silent cosmos, and facing the splintering of our own species if we ever tried to leave. It's a sobering, almost claustrophobic litany of cosmic truths. It's easy to hear this and feel a sense of despair, a feeling of being small and insignificant in a universe that has locked us in a tiny corner. But I want to ask you to consider a radical shift in perspective. What if this confinement isn't a tragedy? What if it's the greatest gift the universe has ever given us? What if our prison is, in fact, a paradise? We so often focus on what is beyond our reach that we forget the sheer, incomprehensible scale of what lies within our grasp. Our prison, the Milky Way galaxy, is an empire so vast we can scarcely imagine it. It contains 400 billion suns. It is home to potentially 100 billion worlds where life could take root. We have not yet even set foot on another planet within our own solar system. We have not explored the oceans of Europa or the methane lakes of Titan. We have not sent probes to even the nearest star systems. We are like a person living in a palace with 1 trillion rooms who spends all their time staring at the wall, lamenting that they cannot see the house across the street. Being trapped grounds us. It forces us to abandon the fantasies of intergalactic conquest and focus on the achievable and, frankly, more meaningful goals of interstellar exploration within our own galaxy. It forces us to confront our own problems here on Earth, because there is no planet B we can escape to in another galaxy. This is it. This is our home. Our cosmic isolation makes life, here and now, infinitely more precious. If the great filter theory is right, and we are one of the few, or only, intelligent species to have made it this far, then we have a cosmic responsibility. We are the custodians of consciousness in this sector of the universe. Our survival, our art, our science, our love, these things might be the rarest phenomena in the entire galaxy. Being trapped gives us a sacred duty to protect this fragile spark of awareness, to cherish our home, and to ensure its survival. The universe has not given us an infinite, meaningless expanse to get lost in. It has given us a bounded realm, a cosmic garden. It is a home vast enough for endless discovery, adventure, and growth, yet small enough that we might, one day, in the far, far future, truly understand it and call it our own. The walls that surround us are not here to crush our spirit. They are here to focus it. They are here to tell us, stop looking out at the impossible void. Look around you. Look at the 100 billion worlds waiting right here. Your adventure is here. Your home is here. Your destiny is here. So, the next time you look up at that beautiful, milky band of stars, don't see the bars of a cage. See the shimmering walls of a paradise that is all our own, a home with more wonders than we could ever exhaust in 1 trillion lifetimes. The lesson in this cosmic story is a deeply human one that we can apply to our own lives every single day. How often do we get trapped by our own impossible dreams. How often do we measure our lives by what is unattainable? The perfect career, the flawless relationship, the life without struggle, and in doing so, fail to see the paradise that is right in front of us? We might not be able to leap to another galaxy, but we can explore the incredible world within our own Milky Way, our own communities, our own potential, the love of the people around us. Our limitations don't have to be our prison. They can be the framework that gives our lives meaning and direction. And by accepting what we cannot do, we are freed to focus on the infinite possibilities of what we can do. Cherish your home, cultivate your garden, and explore the universe that exists within your own reach. That is where you will find your purpose. I'd love to know what you think. Does this idea of being trapped in our galaxy feel limiting to you, or does it feel empowering? What do you think lies beyond the great filter? Let me know your thoughts in the comments below. Thank you so much for joining me on this journey through our cosmic home. I hope it gave you a new perspective on our place in the universe. Please take care of yourselves and each other. And if you enjoyed this exploration and want to dive into more big ideas about science, space, and the human condition, please consider subscribing to the channel. It helps us continue making content just like this. Until next time.